Hi, Dr. Caps. This is Ray Connor here, and this is Lab 2 of Chem 2. And today we're going to do the iodine clock reaction. This is a great demonstration of chemical kinetics and reaction rates. This experiment will show a slow reaction followed by accumulation of iodine ions to a fast reaction. So the idea behind this experiment is to mix two clear substances, and after a certain amount of time, a sudden color change will occur. So two solutions are a solution A and a solution B. So as far as materials are concerned, I have some vitamin C. I'm going to use 2,000 milligrams of vitamin C. I have a 500 milligram container, so I'm already going to bust out, or pull out rather, 4 tablets. I got a muddle to crush that up, so I'm going to go ahead and start that up. Get rid of the smallest pieces I can. Really get it so it can dissolve. Other materials, I have some cups, I have some vases, I've got some distilled water, I've got some coffee filters, I've got a funnel, I got a measuring cup, and I got hydrogen peroxide. I have some iodine, and I have some cornstarch, and I have a note card with some on a marker so we can find out what's going on here. So first I'm going to take that powdered vitamin C that we just did, and I'm going to dump it into our solution here, or one of our cups. I'm going to add 60 milliliters of distilled water. A little bit more than 60 milliliters. And I'm going to stir that up. I'm going to stir this up for 30 seconds. Make sure it's nice and dissolved. Actually, put away my coffee before. As you can see, there was some residue of the iodine from my previous time I attempted this. I've tried this now about 4 or 5 times with very little success. So I'm hoping this one is the one. So I'm going to take my filter, coffee filter with the funnel, and I'm going to pour it. Actually, I'll just pour it right into the vase. And let the vitamin C filter out of this thing. So as that's happening, we'll work on solution B. So for solution B, I'm going to use cornstarch, and I only need a little bit of it, just about at the tip of a teaspoon or tablespoon right here. Pour it in there, and then I'm going to use about 350 milliliters of distilled water. So the thing about this is it's a very concentrated solution. So I've been stirring it up. I stirred it up for like 2 minutes on one of the videos. That didn't work, so I tried it again, and it still wasn't working, so I put it in the microwave for about 3 minutes. That didn't work. I tried stirring it up a little bit more. That didn't work. And so finally, after about an hour and a half, 2 hours, I was able to clear it up a little bit. So I have a little bit of a clear liquid, and as you can see, my vase is all burned. And so I'm going to use this. We'll see. We'll see if this works. So that's right. So I used 0.4 grams of cornstarch, which again was that little bit of the tip there. I used 350 milliliters of distilled water, mix that around like crazy, and now I'm about to add 350 milliliters of, 150 milliliters of hydrogen peroxide. That's a quarter cup, about 50 milliliters. So this is almost completely distilled. Now it's time to add the iodine. at the very end of my iodine, so let's hope this works. As you can see, the vitamin C got rid of the iodine color and made it nice and clear. So essentially what happens is the hydrogen peroxide, H2O2, is in here, is going to mix with the iodine and a hydrogen atom, and it's going to give us a slow reaction. It should be clear, and that's going to create our water, our iodine, and our oxygen, and that's going to go for a certain period of time. And there's different sources of error you can have. If there's too much vitamin C, it'll take a lot slower for the reaction to happen. If there's too much iodine, it'll happen a lot faster. Also temperature-wise. Lower temperatures, slower reaction. Higher temperatures, faster reaction. So when it comes to a fast reaction, we have iodine 2 with an iodine negative charge will actually become triiodide as a fast reaction, so it should be a quick color change. And when that happens, we have the triiodide plus the starch. It's going to give us a black and blue triiodide solution there. So this is what we're going to do. We are going to pour a little bit in here. Keep our fingers crossed that this works. I'm going to use equal parts of both. And so when these two solutions are mixed, it's actually just not one reaction that's happening, it's two. And they're competing reactions and pushing each other back and forth. The hydrogen peroxide wants to oxidize the iodine, the negative charge iodine minus, back to the colored iodine 2. And but the ascorbic acid wants to bring that iodine 2 back to the iodine minus. So this reaction happens really quickly, and the iodine 2 doesn't last for very long and is extremely transient. And so that's, again, hasn't happened yet, so we'll see if it does. But when the vitamin C runs out, the iodine 2 combines with another iodine ion to create that triiodide complex, so that's why it quickly reacts to the starch and creates that blue and black iodide starch complex. So this is still not happening, and I'm running shy or close to the end of the video time limit that I have. So sources of error, as I said, maybe I used too much vitamin C. Maybe I didn't use enough iodine. Maybe I spilled too much and had too much residue in these cups. But theoretically, this was supposed to stay clear, and then within a millisecond, it was going to change colors like that. And that's why it was supposed to be a cool iodine clock reaction. But overall, the timing of the color and change provides information about the rate of reaction, is what we're studying. It makes a useful experiment for studying the reaction of kinetics and the factors that influence them. So that's my video. Unfortunately, my experiment didn't work, but you can't win them all. Thanks for watching. See you next time.